Welcome to ALS Today. This is Michelle Flum reporting. Today, we turn our attention to neuromuscular junctions, NMJs, the structures that keep our muscles and nerves connected. But in people with ALS, these structures crumble, leading to muscle weakness and paralysis. Researchers are working hard to develop treatments for ALS that help keep the motor nerves plugged into muscles in hopes to slow or stop the disease in its tracks. One of these emerging medicines, the NOGO-A antibody ozanezumab, is currently being evaluated in the clinic. Joining us to talk about ozanezumab is Assistance Publique, Hôpitaux de Paris neurologist Pierre-Francois Pradat in Paris. Thank you for joining us, Pierre-Francois.
Hello, Michelle. Thank you for your invitation.
So to get started, what is NOGO-A?
NOGO-A is a protein that is present in the brain and in the spinal cord, and the protein is found in the oligodendrocytes and the myelin membranes. It has been originally discovered through its major role in preventing axonal growth. And scientists think that this protein plays a major role during the development of the CNS in modulated synapse connections. But during the adult life, the protein is still in the CNS and is the main inhibitor of axonal regeneration. Actually, it can be seen as a kind of brake for axonal growth.
So then NOGO-A can become a big problem when axons get injured. Axons are unable to be repaired, regenerated, reconnected back into the central nervous system.
Exactly.
What made you first suspect that reducing levels of NOGO-A might be helpful to treat ALS?
Well, initially, our group have shown that this protein is overexpressed in muscle from ALS patients, and we think that it plays a role in the progression of the disease. In a paper published in Annals of Neurology, we have shown that patients with clinical signs of lower motor neuron involvement and who had high level of NOGO-A were more at risk to develop a typical ALS in the following years. There are also important results in a mouse model of ALS that suggest that NOGO-A is a therapeutic target. Jean-Philippe Loeffler's group in Strasbourg in France showed that in ALS mice, the genetic ablation of NOGO-A prolonged survival and reduced muscle denervation. There is therefore a strong rationale for blocking NOGO-A in ALS patients. First, to slow down the axonal degeneration that begins at the level of the neuromuscular junction, and second, to promote the compensatory axonal smoothing by healthy motor neuron in order to reinnervate muscle fibers. And we hope that it could lead to a functional improvement and survival benefit in patients with ALS.
So you're thinking then, in people with ALS with a lot of NOGO-A, they are unable to repair those axons that get injured through the disease of ALS, unable to be repaired, reconnected into the central nervous system. And then the idea, therefore, is that by reducing NOGO-A, you might enable those motor neuronal axons that have sustained this damage due to ALS to be repaired, reconnected to muscles, helping people with ALS keep moving.
Exactly.
Okay. So can you tell us how researchers now are thinking about how to turn down NOGO-A in patients?
So actually the GSK company has developed a drug called ozanezumab, which is a monoclonal antibody against NOGO-A. This antibody is administered intravenously and reach the neuromuscular junction in order to neutralize the deleterious effect of NOGO-A. And there was a preliminary study presented in a ALS meeting at Sydney, And the conclusion of this study was that the treatment was well tolerated and safe.
So now, ozanezumab is being put to the test in ALS at the phase 2 stage. Can you tell us briefly about the clinical trial that's now ongoing?
Yes, it is actually an international multi-center trial that will include almost 300 patients, and it is a placebo-controlled trial, and the patients will receive the treatment every 2 weeks during a period of 48 weeks. And at the end, the comparison between the placebo group and the treated group will determine if the drug has an effect on the function and also on survival.
Are you planning on using electrical markers, such as electromyography, to evaluate whether the drug is helping indirectly to protect the neuromuscular junctions in people with ALS, keeping the motor nerves and muscles connected?
No, actually, the evaluation is based on clinical parameters, validated and robust clinical parameters. It includes functional scales to evaluate the level of disability, measure of vital capacity for respiratory function, and also, of course, measures of muscle strength. But it's clinical endpoints.
Outcome measures that can help clinicians gauge whether the drug is helping the muscles and motor nerves stay connected, helping people with ALS keep moving and keep breathing.
Yeah, exactly.
One of the most exciting aspects of this treatment strategy is that the drug could potentially treat people with ALS early in the disease course by keeping the muscles and motor nerves connected. What other treatments are in the pipeline to help bolster these connections or just simply help muscles keep moving?
Yeah, actually there is indeed a lot of interest in the ALS scientific community for developing drugs targeting the neuromuscular junction or the muscle itself. And there is a drug under investigation which has been developed by the Cytokinetic company. And this drug is an activator of the skeletal muscle troponin complex. Actually, the goal is to amplify skeletal muscle force production and reduce muscle fatigue. But I think that in the future, new drugs targeting the neuromuscular junction or the muscle itself will be tested. And there is a lot of scientific work about muscle change. For example, our group is now analyzing and comparing muscle change in several motor neuron diseases in an extensive fashion by using high-throughput techniques. And the goal is to better understand the mechanism leading to muscle atrophy in order to individualize therapeutic targets. And another strategy, we have also shown and published that muscle stem cells are dysfunctional in ALS. Restoring the function of these muscle stem cells may allow to promote muscle repair, and I think that it's also an innovative and new strategy.
Which is really exciting. New ideas, new treatments in hopes to help people with ALS keep moving.
We hope so.
I want to thank you for joining us today, Pierre-Francois.
Thank you very much, Michelle.
This is Michelle Flum reporting from Cambridge, Massachusetts.